So we're still in Chapter 1, Equations and Inequalities. And Section 1.6 is Equations and Inequalities involving absolute value. So our first objective is to solve equations involving absolute value and there's going to be a certain strategy for that, and then there's going to be solve inequalities involving absolute value, and that's going to be very different. So you're going to have different strategies for these two things. So I want to introduce the topic by asking you, how many solutions are there to the equation absolute value of x equals 3? So think about it, and I think you'll agree that I get two solutions, either x equals 3 or x equals -3. So two solutions. But now think about this next equation. The absolute value of x equals -4. Well, I think we'd agree that the absolute value has the property that it makes things positive. So it's never going to be equal to -4. So your answer will be no solution. If somebody asks you to solve the absolute value of a quantity equals a negative number, you should say, well, that never happens. So there's no solution. So when we're solving equations and inequalities involving absolute value, the most useful way of thinking about absolute value is distance from the center of an interval. So this may be a new way of thinking about it for you. So we can interpret or rewrite the absolute value of x as the absolute value of x minus 0, because adding or subtracting 0 doesn't change anything. So the only reason I'm doing this is so that you can see a pattern here. So this 0 we'll call the center, so that's the center of an interval. And then this 3 is the distance from the center. So you go 3 this way, 3 this way, and here are your two solutions, each 3 away from the center of the interval at 0. So let's look at this next one. 2 is the center of the interval. So 2 is the center of the interval. 7 is how far we go each way. 1, 2, 3, 4, 5, 6, 7. So that's going to be 9. And -5. So the two numbers that are each a distance of 7 away from the number 2 is -5 and 9. So what if we just write it as x minus a equals 5? Well, now we have just some unknown thing a as the center of the interval. And we'd say go 5 to the right. Well, that number is a plus 5. Then we'd say go 5 to the left. And that number is a minus 5. So those are our two solutions. X equals a plus 5 or x equals a minus 5. Okay, so we have a theorem we can work with here that says if a is a positive real number, so imagine in your mind the right side of the number line. A is a positive real number, and u is any algebraic expression. Then the absolute value of u equals a is equivalent to saying either u equals a or u equals the opposite of a. So this should remind you of the square root property that we say if u squared equals a, then u equals plus or minus the square root of a. You get two answers. So does this seem kind of similar of what if I said u squared equals 5, then u equals plus or minus square root of 5. These two ideas are related because another way of defining the absolute value is to say it's the square root of u squared. So I'll let you think about that for a minute. So here's find the real solutions if any of these equations, and we're going to look at those in class together. And always before solving an absolute value equation, isolate the absolute value. So this sentence should start becoming familiar to you because isolate the interesting thing comes up a lot. Isolate the logarithm, isolate the exponential, isolate the radical, isolate the absolute value. That's becoming a common thread. So hopefully you've got that kind of implanted in your brain. So an important idea about absolute value is the idea of the two solutions. It's really easy to lose track of that second solution if you're not thinking about absolute values. Okay, so the equations aren't too bad, but now let's consider the inequality. The absolute value of x is smaller than 3. And let's interpret this inequality in light of what we learned about absolute value indicating distance from. So the distance from something. So that's why absolute value is always positive, because your distance from something is always measured in a positive way. So the solution set of an absolute value inequality could be an interval or a chunk of the number line. So if we have the absolute value of x is smaller than 3, and we say, well, that's the same thing as saying the absolute value of x minus 0 is smaller than 3. So we're saying there's an interval where 0 is in the middle, 3 is one edge, and negative 3 is the other edge. And we're saying this distance needs to be smaller than 3. So we want all the guys inside here, but not the end points. So see if that works. If you put 2 in there, yep, the absolute value of 2 is smaller than 3. What if you put negative 2? That also works. So your solution is an interval, all the numbers between negative 3 and 3, not including the endpoints. So let's think about, what about the absolute value of x is smaller than negative 2? Let's start back in the previous page where we said the absolute value of x, could it be equal to negative 2? No possible way, because it's never negative. Zero's the smallest it can get. So there's no way the absolute value of x could ever be smaller than negative 2. So again, there's no solution to this absolute value. So that gives us another possible answer when we're asked to solve an absolute value inequality. So your text separates solving absolute value inequalities into two cases. Case 1 is where the absolute value of a quantity is smaller than a number. So that's similar to this one we just did here. And the absolute value of that quantity is bigger than a number, in which case you get a very different looking answer. So let's look at case 1 first, which is the example we just did, where we have the absolute value of something is smaller than a number. So here's the theorem. If a is a positive number, and if u is an algebraic expression, so any kind of algebraic expression with x's in it or not, then the absolute value of u is smaller than a is equivalent to the compound inequality negative a is smaller than u is smaller than a. So this should remind you of the previous section when we were solving this type of compound inequalities. And if you have the or equal to, the absolute value of u is less than or equal to a, then you put the or equal to symbols on the inequalities. So in other words, the absolute value of u is less than a is equivalent to negative a is less than u and u is less than a. So remember that when you write the compound inequality, the and is implied. So answers to absolute value inequalities have three parts, just like we were talking about in section 1.5. You have the inequality, which goes into your set notation. The set of all u such that you have your inequality, but you've solved for x in our case. You have a graph of the solution set. And if you have only one variable, you only need one number line to graph solution sets. So the solutions, when it says graph the solution set, it means on a number line. And then we have interval notation. So three ways of showing our answer. All three parts have to be included for a complete answer that gets full credit. Okay, so we're going to do these examples in class together so we can practice, because I want to talk about case 2, and that's if you have the absolute value of a quantity is greater than a number. So let's think about absolute value of x is bigger than 2. Again, we can think of this as absolute value of x minus 0, where we have 0 as the center of an interval, and then 2 is the distance from the center. So this is a distance of 2 and a distance of 2. But now we want that distance, think about absolute value as distance, to be bigger than 2. So I want these tails of the number line, not the part in the middle. This is pretty easy to check and make sure you got the right part. So if I try 0 in the inequality, it's not true. So I'm happy that I didn't include 0 in my interval. If I put 10 in there, I get true statement. If I put negative 10, I get a true statement. So I'm feeling pretty comfortable about my answer. So I have negative infinity to negative 2, and then we put a u for the union. When you have two pieces of the number line, this is the symbol that you use, and it indicates the union of two sets. It means everybody that's in the first set or anybody that's in the second set. So here's the theorem that goes with this. If a is a positive number, and u is an algebraic expression, then the absolute value of u is bigger than a is equivalent to u is less than negative a, or u is greater than a. There's no way to write as a single inequality. This kind has to be done with two pieces. And if you have the or equal to, you'd have u is less than or equal to negative a, or u is greater than or equal to a. So there's no way to write it as a single compound inequality. There will always be two parts to the solution set when you have absolute value is bigger than a number. And then let's talk about this special case. What if I say, when is the absolute value of a number bigger than negative 6? And let's talk about that in class of what is the solution and how do you write it. And then we have some more examples, and that's it.